Welcome to another video of anatomy and physiology. In this video we're going to be discussing the cardiovascular system, your circular system. This is the first of 3 videos where we'll be discussing the flow of blood throughout the entire body. So we're going to first start off with the heart, and as we start off I want to discuss the location of the heart. As you can see here, it's located within the thoracic cage, protected by your sternum, and it lies within your second rib and your fifth rib. Okay, so on the posterior end, it is protected by your vertebrae, your spine. So as you can see, the heart is a vital organ. It is well protected by the body. It's about the size of your fist. Pumps about 100,000 times a minute. 100,000 times a day. And of course, that's an average. And it pumps about 2,000 gallons of blood on a given day. So that's pretty amazing. When you think about how long the heart lasts, it's one of the most amazing pieces of human machinery that we know of. Nothing that, when I think about my car and how reliable it is, it's still not going to last, a lifetime. Cars need to have parts replaced, but the heart, as much friction as it goes through and constant motion, never stopping, and it still works in a given lifetime. So quite a piece of machinery, an awesome organ, if you ask me. One of my favorites. So let's go ahead and get into this, okay? Okay, so we're taking an anterior look of the heart right here. Okay, so I have pretty much all the major vessels that we'll be discussing in this video. We're going to start off. We're going to start our journey, the flow of blood, from our superior, inferior vena cava, and then the other major drainage system, the coronary sinus. Now, your inferior vena cava drains the blood from the lower limbs, abdominal and lower limbs, and then your superior vena cava drains the head and arm, and then your coronary sinus drains the blood that is used up by the heart itself. Okay, so this venous system is draining blood into your right atrium. Okay, and this blood is all deoxygenated. It's used up blood by all the cells, and it is full of carbon dioxide. So it needs to get pumped into the lungs and reoxygenated. So it fills up the right atrium, okay, and then it flows through what's called a tricuspid valve, okay. This valve prevents backflow, and these tricuspid valves are anchored in by, let me zoom in a little bit. They're anchored in by what's called your chordae tendineae. And these are very strong ligaments, and the other cuspid valve also has chordae tendineae. Very strong ligaments that, like I mentioned before, anchor these valves in. Okay, these are like to call the strings of the heart. Okay, when I was in high school, when I first dissected the heart, and one of my favorite instruments was the violin, and all of a sudden it all made sense to me, because the violin plays on the strings of the heart, and well, here are those strings, the chordae tendineae. So in any case, so the right ventricle is now filled with blood, and again it is deoxygenated blood, and it does not flow back because of these valves. So once the ventricles contract, okay, and both ventricles contract at the same time, okay, blood from the right ventricle then flows through what's called your pulmonary valves. Okay, and as this pulmonary trunk gets filled, the blood wants to flow back, but again it doesn't because of these valves right here. Okay, let me kind of zero in on them a little bit. All right. In fact, here, let me hide them so you can now see inside the pulmonary trunk. Okay. So here we have the view of the pulmonary trunk, and these lead into your pulmonary arteries. Okay, so let me actually hide these lobes on the right side. So they flow into the pulmonary arteries, where the exchange of carbon dioxide, which gets diffused from the blood into your lungs, and then the oxygen that's in the lungs gets diffused into your bloodstream. Okay, so again, these are pulmonary arteries. Remember, the term artery is referring to the direction of which the blood is flowing, and in this case, the blood is flowing away from the heart. So those are the arteries. So I want to just help you differentiate your pulmonary veins and arteries. So if the blood that's leaving the right ventricle is deoxygenated, you know it needs to get oxygenated, so it's going to go towards to the lungs, away from the heart. Okay, so these pulmonary arteries go with the right ventricle, and you can see the pulmonary trunk, for example, and arteries. You get a better view of those if you're looking at the heart from the anterior view. But for the pulmonary veins, which is the blood, once the blood has been oxygenated in the lungs, it wants to return to the heart, and those you actually get a better view of those if you look at the posterior aspect of the heart, and then you see the left atrium, and then from there you can get a closer look, and you can see the pulmonary veins coming through on the posterior side. Okay, and then just superior to that left atrium, you can see the trachea, where the air comes in and out of the body. Okay, so I hope that helps you differentiate the different tubing in the heart. Okay, and let me go ahead and delete or remove these lungs so you can get a better view. Okay, so they drain into the left atrium, and then they drain through your mitral valve, okay, or your bicuspid valve. Let me hide this valve so you can get a look inside the left atrium. Okay, and that's this space in here. So then, so the atrium contract, and just as a reminder, these contract at the same time, filling in the ventricles at the same time. So these two contract, and then your left ventricle gets full of blood. Now, one thing I want you to take notice of is the fact that the muscle that surrounds the left atrium is much thicker than the muscle, the myocardium, that surrounds the right atrium, right ventricle, sorry. The reason for that is because the amount of force that's required to pump this blood into the body is much higher than the force required to pump the blood from the right ventricle into just your lungs. Okay, you don't need a lot of force there. But here, this blood that's now oxygenated, that now fills the right ventricle, needs to go out throughout the entire blood. So so that muscle is much thicker to supply that force. So this right atrium fills up, the muscle contracts, the heart contracts, and then it goes into, right over here you can see, your aortic valve. Okay, and that goes through this one right here. Okay, so your aortic valve. So now we're going through your aorta, which will lead to the entire body. Okay, one thing I want to mention as well, in regards to these valves prevent the backflow of blood. Just as an example, so once your right ventricle fills up and it goes into the aortic valve, the blood naturally wants to flow back. But these valves, once the pressure starts going in from that direction, these valves will close up, and they prevent backflow of blood. So the blood ends up in the aortic arch, and this is actually where we'll stop this video. But before I do, I want to mention one other thing. So once the oxygenated blood reaches the aortic base, the first organ to receive blood, the one that has first dibs, is actually the heart itself. And it receives this blood by what I have highlighted here. So if I can zero in on that. That's my right coronary artery. Okay? And then there's another one that lies posterior to it. Let's see if we can get it. No, can't see it from here. So let me see if I can remove. I'm going to remove my base of my pulmonary trunk. There it is. So, so you can see these two arteries, my right coronary and my left coronary. So these are the first ones to receive oxygenated blood. So the heart feeds itself first and foremost before it then feeds the entire body via the aorta. Okay, so that does it for these the blood cycle through the heart, and we'll continue on the next video following our aortic arch.